Okay. All right. So we're going to continue on with our notes from yesterday. The mole is kind of a bit of a tricky concept, and converting between like volume and grams and moles of something can be a little bit it can seem a little trickier than it is to get started. So I just want to make sure that we're spending a lot of time on this and you all are fully grasping it before we kind of move too fast into something else. All right. So everybody's got this note set out in front of them? Okay, Charlie, Casey, do you guys have this in front of you? Okay. All right, so make sure you've got this in front of you. You lost your pen? I have pencil crayons up here. Oh, yes, please. Thank you. All right. So everybody, so far what we've talked about is how to convert between moles and mass. Can I just get phones away and eyes up here, please? Thank you. Okay. So far what we've learned to do is convert between moles and mass. So again, 1 mole being 6.022 times 10 to the 23. So just a huge, huge number of particles. And mass in grams. And that's what you all did yesterday when you measured things out. So you were going, all right, grams per mole is my molar mass. And you figured out the molar mass of whatever your substance was, whether it was sugar or baking soda or iron or copper. And then you measured out however many grams are in 1 mole of that. So that's what we did yesterday. And then we talked about volume as well. So the volume of 1 mole of gas, and I guess you all have this out in front of you, but the number, again, is 22.4 liters at standard temperature and pressure. So at standard temperature and pressure, being 0 degrees Celsius and 101.325 kilopascals, 1 mole of gas occupies 22.4 liters. Did everybody do these practice questions on page 83? Yeah, did we all feel okay about them? Somewhat? You didn't get 12? Okay, so then let's go through 12 together. Where is my chemistry textbook? I've got a chemistry 12 book up here. Okay, so question 12. Did everybody at least try question 12? So this is page 83. If you don't have your book out, just grab it and we'll flip to page 83 and we'll go through this example together. Okay, so page 83, question number 12, is calculating the number of moles of gases at standard temperature and pressure. And I asked you all to do all of them. Perfect. Okay, so in A, we have got 85.9 liters of H2, hydrogen gas. All right. Now, what we're looking for is how many moles of this is that? And another thing that we know is 1 mole, and we're assuming in these questions, unless it's otherwise specified, that everything is at standard temperature and pressure. 1 mole equals 22.4 liters. When we have something like this, we can turn it into a conversion factor. So 1 mole per 22.4 liters. Does that look a little bit more kind of familiar from like what we were doing in our other unit, our math unit? All right, so let's set this up. So if I've got 85.9 liters and I want to cancel out the liters and get moles, I'm going to multiply this by 1 mole per 22.4 liters. And that cancels out that unit. So we have to divide 85.9 by 22.4. And what do we get if we do that? So everybody got a calculator? 3.8? Awesome. Okay, so 3.8 moles. Let's try B. So B is asking, whoops, I went to the wrong page here. Okay, page A3. Okay, B, I have got 375 milliliters of SO3 gas. Okay, so let's think about this. If I have got 375 milliliters, and I know that there's 1 mole in every 22.4 liters, can I just do a direct conversion from milliliters and liters into moles, or do I need to do a step in between? Yeah, what do I need to do? Turn milliliters into liters, exactly. Yeah, so 375 milliliters, I need to make this into liters. When we're going from milliliters to liters, does anybody remember how many milliliters are in 1 liter? 1,000. So I'm just going to move my decimal over 3 places there, and I've got 0.375 liters. Okay. So now this is a very similar question to the one up here. I'm just going to go 0.375 liters times 1 mole per every 22.4 liters. Doing this cancels out my liters. And if I do 0.375 divided by 22.4, what do I get? 0. What? 0.00? Okay, good. 0.0 yeah, 167.4 blah blah blah. But how many sig figs do I have here? So yeah, 3 in my that, and I know 22.4 liters. So I'm gonna go to here, right? 0.0167 moles. And if you wanted to, you could put this into scientific notation and do 1.67 times 10 to the negative 2, but this is fine as well. So I don't even have close to 1 mole of gas in this example. All right. Let's do C as well. So C is 5.00 milliliters of OCl2 gas. Okay, I want you guys all to do this one if you haven't done it already. I'm going to give you a couple minutes. At least try to set it up, and then we'll do the answer together. Okay, what is the first thing I need to do here? What's the first thing that you guys did? Yes, awesome. So how many liters is 5 milliliters? Yeah, awesome. 0.005 liters. Okay. And then what did everybody do after that? Yeah, multiply by 1 mole for every 22.4 liters. That's canceling out my liters and leaving me with the unit of moles. And what did people get for that? .0175. Oh, okay. Times 10 to the negative 1. Oh, yep, awesome. Okay, so I'm going to end up getting something that looks like this on my calculator. Whoops, that's a 2. Okay. And then I'm going to go back and look how many sig figs I have. So this was written out, 5.00 milliliters. That gives me how many sig figs? 3. Any decimals that are after a 0 like this are significant. 22.4, 3. So I'm looking at these 3 figures here as being significant. So you could write 0.000223 moles. See you later. Or you could go, what, you did that? Marcus did that? Okay, you do what Marcus did and go 2.23 times 10 to the negative 1234 moles. Either way is totally fine, but just make sure that you all are keeping track of your sig figs when you're doing this. Does that feel okay for the gases and the volume? A little more clear? Okay, cool. Any questions about how we got from like here to here? Okay. One thing that is just worth noting, when you are looking for the mass in grams, you're going to be looking at this compound, whatever it is, and finding its molar mass. When you're doing volume calculations like that, we don't need that. We're just looking for volume and moles. So you don't need to calculate the molar mass when we're doing this. Alrighty. So let's get into our next conversion for the mole, which is going from mole to particle. So we know that 1 mole is 6.022 times 10 to the 23. We'll never get tired of that number, particles. So just to compare it again to a dozen represents 12 objects. What is something that you often hear a dozen about? Eggs, yes. But 12 objects could be anything. You could have a dozen books. You could have a dozen friends. You could have a dozen people in your bubble by June. Who knows? What'll happen? So a dozen is just a number that means you've got 12 of something. But a dozen does not represent the same mass. So like a dozen grapefruits, for example, does not have the same mass as a dozen grapes. Yeah, it doesn't have the same mass as a dozen grapes. So you can still, you've got 12 of both things. The mass is very different. And we saw this yesterday when we were looking at 1 mole of sugar had significantly more mass than 1 mole of copper did. Okay, so the mole measurement is the same kind of concept. Whoops, measurement. It's the same concept as a dozen. So it represents just a certain number of objects. just like how we usually talk about eggs in a dozen and not really other things, we usually talk about molecules in a mole, and we don't normally talk about other things as a mole just because it's a very unique number to this concept. So having 1 mole or 2 moles or whatever of a molecule makes sense. Having 1 mole of books or 1 mole of eggs would just be like absolutely ridiculous. Yeah. So it's just a measurement, it's just a number, and we call it a mole. And again, 1 mole is the amount of substance that contains particles. These particles can be atoms. They can be molecules. What's the difference between an atom and a molecule? Exactly, yeah. So a molecule is going to be more than 1 atom together. So you can have a mole of a single atom, such as like chlorine or copper, or you could have a mole of a molecule, such as water, which is H2O. Is it always going to be water? The molecule? No. Okay. Good. All right. So this number, again, we talked about this guy yesterday, Avogadro. Did everybody see my great Avogadro joke this morning? Was anybody late? It's worth seeing it again. It's just so good. Look at how funny this is. This is Avogadro saying, take my number. And that's his number. All right. Thank you. I'm going to hang that all over the school on Mole Day, just so you guys know. Okay. So, so 1 mole. We're just going to like repeat this a whole bunch of times to really solidify it into your head. 1 mole is that many particles. And this is another unitary rate. And we can use it to convert between moles of a substance and particles of a substance. Really, at the end of the day, when we're talking about how many moles of something we have, we are talking about how many particles of that thing that we have. But the number of particles we're dealing with is just such a huge number that it makes sense to assign a certain number of them to a mole. 1 mole of dollars would be enough to guarantee every person in the world an income of $3 million per second for 100 years. That's wild. But a mole of carbon-12 just has a mass of 12 grams. So yeah, that's just this is a really large number, and atoms are tiny. They are very, very small things. Okay, so let's figure out how many moles of water are in 3.01 times 10 to the 23 molecules of water. So first off, just by looking at that, do we have 1 mole or less than 1 mole? We have less than 1 mole. Yep. Okay, so what we want to know is how many moles of water. So we're going to go, we have got 3.01 times 10 to the 23 molecules. And then we know that 1 mole of water is 6.022 times 10 to the 23 molecules. So we're canceling out the unit of molecules here. And what we're going to end up with is 0.500 moles moles. So it's half of a mole. Okay, and then we're going to figure out in the next question, how many carbon atoms. So in this one, we're saying molecules because water is a molecule. In this one, we're saying atoms because carbon is just a single element. It's a single atom. So how many carbon atoms are there in 0.75 moles of carbon? So I have got 0.75 moles. So we're doing the opposite of what we did in the last one. So I'm going to throw my moles on the bottom this time. So 1 mole is 6.022 times 10 to the 23 atoms. That's canceling out moles and leaving me with atoms of C, carbon. So I'm going to do 0.75 multiplied by this huge number. And what I'm going to end up with is 4.5 times 10 to the 23 atoms of carbon. So just a note, sometimes these questions will say molecules, sometimes they'll say atoms. It's just dependent on whether we're looking at an atom or a molecule. Okay, next question. A variety of carbon atoms. I've got the molecular formulas from yesterday written down here. Ignore those. A particular variety of carbon atoms has a mass of 2.16 times 10 to the negative 23 grams per atom. Okay. So now what we're going to look for here is the mass of 1 mole of this variety of carbon atom. So do you remember how I said that sometimes carbon has different numbers of neutrons and it can have different masses? Yeah? Okay, so this is in a situation like that. We're trying to figure out what the mass of 1 mole of this variety of carbon atom is. So we want to know grams per mole. That's what we're looking for of carbon. So we know that we've got 2.16 times 10 to the negative 23 grams per 1 atom. And we know that there are 6.022 times 10 to the 23 atoms in 1 mole. If you're not sure where to start with something, I would really just recommend listing like off to the side, what am I looking for? What do I have? And then kind of go from there. Okay, so it doesn't really matter what order I put these in. I'm just going to start with this. I've got 2.16 times 10 to the negative 23 grams per 1 atom. Okay, and if I'm ending up with grams per mole, how do I want to put this second unitary rate? Should I put the atoms on the top or moles on the top? Yep, exactly. I want to cancel out atoms and I want to end up with grams per mole. Okay, so I'm getting rid of atoms. What I'm left with is grams per mole, which is what I want. So 2.16 times 10 to the negative 23 times 6.022 times 10 to the 23 ends up being 13 grams per mole. So this specific variety of carbon would be called carbon 13. That's a G, not a 9. Yes. Yep. No, so there's this many atoms in 1 mole. So, yeah. Okay. Light bulb went off. That's good. Yep. Yeah, exactly. So basically, all you're looking to do with these questions is you're just canceling stuff out, everybody. We're just canceling things out and looking for a missing unit. Okay, so let's start on this. We're going to do page 84, 15 to 17. And then there's a worksheet called More Mole Calculations. I've got it at the front. I think some of you picked it up yesterday. Let's pause after 15 minutes and go through a few together if we're having a hard time with them. But we'll work on that until about 1:30.